relation? A relation gives us a set of ordered pairs that satisfy a relationship. Let's understand this using an example of two sets. We have two sets P and Q. Set P has elements 2 and 4 and set Q has elements 10, 20 and 35. We first take the Cartesian product of the two sets. Let's use an arrow diagram for the Cartesian product of sets P and Q. So P cross Q is a set of the following ordered pairs. It's 2 paired with each of these 3 and then 4 paired with each of these 3. We get 6 ordered pairs of the form P, Q where every P belongs to set P and every Q belongs to set Q. That's how it can be written in the set builder form. Now let's introduce a relation R. Relation R gives us a set of all ordered pairs that satisfy a relation. It could be any relation. Now, suppose we introduce a relation R' such that Q is a multiple of P. So we can say that relation R' gives us a set of all ordered pairs P, Q where Q is the multiple of P. Every ordered pair in the set R' satisfies the relation R'. This is the set builder method to represent R'. Please note that Q has to be a multiple of P here. Now let's choose ordered pairs from a Cartesian product P cross Q that satisfies the relation R'. Look at the ordered pairs in the Cartesian product. Notice that 10 is a multiple of 2, 20 is a multiple of 2 and 20 is a multiple of 4. So we get the ordered pairs 2, 10, 2, 20 and 4, 20 such that every ordered pair satisfies the relation Q is a multiple of P. This is the roster method to represent set R'. Roster means list. So we can say that the ordered pairs in set R' are all listed like in a roster. Set R' can also be represented using an arrow diagram. We draw an arrow for every ordered pair in set R'. So we draw one arrow for 2, 10, another arrow for 2, 20 and another arrow for 4, 20. Let's say this entire circle represents the set of elements in the Cartesian product P cross Q. In that case, set R' will be a part of it. We can say that set R' is a subset of the Cartesian product P cross Q. That's the basic concept of a relation. A relation gives us a set of ordered pairs that satisfy a relationship.